In example B3, we continue with the same k-bord reliability problem, but with a twist. It's still a 2 random variable problem, but we have a new random variable, the cross-sectional area, and we treat the load as a deterministic quantity. So y and a, the yield strength and the cross-sectional area, are random. The load is not. So let's take a minute to read the problem and then solve it. Y and a are both log normally distributed, so it makes sense to choose x1 as log of y and x2 as log of a, so that we have a limit state that still is linear in the basic variable space. So that is g, x1 plus x2 minus log of q. Then we have to choose a transformation. We continue with the second moment transformation as we did in the previous examples. So u is x minus mean over the standard deviation. So that gives us a linear limit state in the u space as before, and we have done the computations for the mean and sigma of log y and log a respectively. So what you see on the screen is the final output of that. It's a linear function in terms of u1 and u2. The only unknown constant is the mean of log a, which is going to give us the log of a once we solve it. So here is the solution. Beta, which is a function of mu of log a, has to equal 3, which is the problem statement. So that gives us a mean of log a of 3.99, which gives a mean of a as 54 square inch. So it's in the same ballpark figure of mean of 50 that we had before, 50 square inch. Now let us, as we have been doing, find the checking point values, the most likely points, and here something interesting happens. The problem identifies both y and a as strength type variables, because clearly we see that the minimum the checking point for both of them are in the lower end of the distribution. So u1 star is 2.5 standard deviations below the mean, and u2 star is 1.7 standard deviations below the mean. That gives us the checking point or design point values in the basic variable and physical variable space as 26 ksi and 46 square inch respectively. Now obviously these numbers are different from what we had before, because now the problem statement has changed. Y is log normal, A is log normal, Q is not random at all. So this was another example of a 2 random variable problem solved for the k-bord reliability example.